Hi, grade 10s. Mr. McLeod here. Tell you a little bit about factored form of quadratic relations. So, factored form is really useful form uh, for finding the x-intercepts as we learned yesterday. So here we have a quadratic relation. This is called expanded form. Notice that it's a series of terms. And of course, factored form will convert it into a series of factors that are being multiplied together. Okay, so here we go. Let's factor this. So when we're factoring, we always look for a common factor. And here, 4, each term is divisible by 4, so 4 is a common factor. So we divide out 4 as a common factor. Okay, now we notice we have this simple trinomial inside the brackets. And so we look for two numbers and multiply to get -8 and also add up to -7. And those two numbers are -8 and 1 plus 1. Okay, now this relation is in factored form. These numbers here, as we learned yesterday, tell us what the x-intercepts are, except for we take the opposite value. Why do we take the opposite value? Because it's the value that makes each factor equal to 0. So for example, if we were to replace x with +8, then in this factor here, we got 8 minus 8 is 0. And then 0 times whatever's in this brackets is 0, and 0 times that is 0. So it's, again, the x-intercepts are the values for x that make the equation equal to 0. Over here, if we were to replace x with -1, then we get -1 plus 1 is 0, and 0 times all the rest of it is just going to be 0. So that's why we take the opposite values of those numbers that are inside the brackets. Now we're going to come up with a general form for this. So we represent these numbers inside the brackets, the x-intercepts, or zeros as we call them, by the letters S and T. Now you notice that sometimes we have a number in front of the brackets here, and we're going to call this number A. So that's just our name for just if there's a number in front of the brackets, we're going to call that A, and the two numbers in the brackets are we're going to call S and T. So here it is, the general form of factored form quadratic relation. Y equals A, x minus S, x minus T. S and T, of course, represent the x-intercepts, and A is the number that's in front of the brackets. Now, A also tells us something interesting, and that is that when A is a positive number, the parabola opens up, and when A is a negative number, the parabola opens down. So just from looking at this equation, we can tell a lot about what the parabola looks like on the graph, whether it opens up or down, and where the x-intercepts happen to be. Okay, so let's put this to use. We're going to use this to determine the equation of a parabola. So here's our parabola here. When we want to determine the equation of the parabola, we start with the general factored form, which is y equals a x minus s, x minus t. All right, so if we can fill in the a, the s, and the t, then we'll have ourselves a quadratic relation. So what information can we determine from the graph? Well, we know where it crosses the x-axis. These will give us our x-intercepts, or in this form, s and t. So we could call this x-intercept s and this one t. Of course, it doesn't matter which one is which. Now, a is usually going to be the one that we're not given explicitly. So what can we do? Well, if we find some other points on the parabola, those have the coordinates of x and y, and so we can fill in the x and y with some other point on the parabola and then determine what the a is. So when you're finding the equation of a parabola, usually the goal is to use the x-intercepts and also another point on the parabola, which gives you an x and a y coordinate, to find a. So what other point can we find on this parabola? Oftentimes the vertex is a great point. So in this case here, the vertex located at 2 and -8, 2 and -8. Okay, and this gives us an x and a y value that we can fill in the general form. Okay, so here we go. So y is -8a, and because we're subbing into x's inside brackets, I'm going to use square brackets on the outside. So we have our x value is 2 minus s is at 0, and our x value is 2, and our t value is going to be 4. Okay, so notice that we have one x value, and then there are two x's in the equation. So you sub that same value in for every x that there is in there. So I don't know if that's been a cause of any confusion for you. All right, so let's simplify, and then we'll solve for a. So we have -8 equals a. 2 minus 0 is 2, and 2 minus 4 is -2, right? Okay, simplify that. A 2 times -2 is -4, and we get a by itself by dividing both sides by -4. So a is -8 divided by -4 is +2. And notice that it makes sense that we get a +2 as our a value, because a positive a value indicates the parabola opening up, and as you can see from the graph, this parabola opens up. Okay, now we can sub in our a, s, and t into the general form and have our equation. So here we go. Y is equal to 2 times x minus 0 and x minus 4. If we simplify, we have 2. X minus 0 is just x, and x minus 4 is x minus 4. So here is our equation. Y is equal to 2x and x minus 4 in factored form. Let's do one more. Here we have another parabola. We can identify where the x-intercepts are. Let's call this one S. We'll call this one T. This one occurs at -5, and this one occurs at +3. And it'd be nice if we had some other point on the parabola. Now notice that the coordinates of the vertex here are not easy to identify accurately because it doesn't pass through the corner of a box. So we can use it. We can use any points really. So why don't we use the y-intercept, which is right here. And the coordinates of this point are 0 and 5. And of course that gives us an x-coordinate and a y-coordinate. Okay, here we go. Our general form is y equals a x minus s, x minus t. Sub in our x and y. Here we go. Y is 5. Our a value is what we're trying to find. Our x value is 0. Minus s is -5. X value is 0. Our t value is 3. Simplify inside the brackets. 0 minus -5 is like 0 plus 5, which is 5. 0 minus -3 is -3. 5 times -3 is -15. Divide both sides by 15. Whoops. And a is negative 1/3. And it makes sense that a is negative because in this case the parabola is opening downward. Okay, now we can sub in our a, s, and t, and we'll have our equation in factored form. So y is equal to, a value is negative 1/3. Our s is negative 5. And our t is 3. So simplify. Negative 1/3. X, subtracting a negative is like plus 5. And x minus 3. So there it is. There is our equation of this parabola in factored form. And again, you can do yourself a little check. If there is a positive 5 inside the bracket, then the x-intercept should be negative 5. It's the opposite value. And this one here, the number inside the brackets is negative 3, which means that the x-intercept should be positive 3. So there it is. I hope this made some sense to you. Keep asking questions if something doesn't make sense. Finding the x-intercepts of a quadratic relation is very useful for solving problems. So we'll be doing this a fair amount in the future. So that's it for now. Bye.